In the previous lecture, we have seen this value of R1 and R2, and now we are going to take the reciprocal. So 1 upon R1 is equal to 1 upon R into bracket 1 plus L square upon R square minus 2 R L upon R square. So one of the R will get cancelled into cos theta raised to minus half. So now this I can write down 1 upon R into bracket 1 minus 2L upon R into cos theta raised to minus half. How? We are going to neglect this term L square upon R square. Why? L is half of the magnetic length. This L value is very smaller than R. Therefore, this L square upon R square, this value is neglected. And if this value is neglected, I can neglect this term and I can write in this manner. Now, here we are using a binomial theorem. What that binomial theorem is that 1 plus x raised to n can be written as first term as it is 1 plus second term will be multiplied by power, that is nx, and the higher terms are neglected. So that using that binomial theorem, now we can switch over to your value of 1 upon R1 is equal to 1 upon R inside the bracket. 1 is the first term, twice L upon R cos of theta is cos of theta is second term, and the power is minus half. So first term as it is, so 1 as it is, minus power is minus half, so minus half into the next term is, x term is twice L upon R cos of theta, and the higher terms are neglected. So now this 2 factor will get cancelled. So if this 2 will get cancelled, I can cancel out this 2. This minus will become plus, and now your term will become 1 plus L upon R cos of theta. So your 1 upon R1 is equal to 1 upon R1 into bracket 1 plus L by R cos of theta. Similarly, now I can write down the value of R2. So your value of R2 is what? 1 upon R2 is equal to 1 upon R, and here is the plus sign. So same thing I will get it here. So here I will say 1 upon R2 is equal to 1 by R1 plus twice L upon R cos of theta raised to minus 1. Again this L square by R square term is neglected. I can use again the binomial theorem, and if I use the binomial theorem, using this binomial theorem I can write down 1 upon R2 is equal to 1 upon R in bracket first term as it is plus power is minus half multiplied by second term is twice L upon R cos of theta. So this 2 will get cancelled, plus into minus means it will become minus, so your term will become as a 1 upon R2 is equal to 1 upon R into bracket 1 minus L by R cos of theta. So this is your 1 by R1, 1 by R2, and this term is your 1 by R1. Now using that term, now I can write down here as 1 upon R1 minus 1 upon R2 can be written as, so these are the two terms, in that 1 by R is common. Inside the bracket, first term is 1 plus L by R cos of theta minus into second term is 1 minus L by R cos of theta. So now I can write down here as it is equal to, if I open the bracket, so this term will become plus 1 minus 1 will get cancelled, L by R cos theta plus L by R cos theta, so it will become 1 by R into bracket twice L upon R cos of theta, which is equal to nothing but your 1 by R1 minus 1 by R2. And what is your potential? Potential V is equal to, I can write down 1 upon 4 pi epsilon naught Q inside the bracket 1 by R1 minus 1 by R2. This is your potential due to dipole. In that I can substitute the value. So instead of 1 by R1 minus 1 by R2, I can substitute this equational value. So your equational value, if I substitute here, so I am getting here twice L cos of theta divided by R square. Now in that, this Q multiplied by twice L, that is nothing but your dipole moment. So it will become V is equal to 1 upon 4 pi epsilon naught into bracket. Instead of Q into 2L, I can substitute P cos of theta upon R square. So this is nothing but your electric potential due to a dipole. Now in this equation, for this equation we can consider the special cases. What that special cases are? First I can consider that your given point will be lying along the magnetic dipole. So if it is lying along the magnetic dipole, your theta value will reduces to 0. And if theta is equal to 0, cos of theta, which is equal to cos of 0, will reduce to 1. So now your potential along the axial point. Now theta is 0 means what? Your point P is lying along the dipole axis. So that's why this electric potential along the axis, now it will become, according to formula is 1 upon 4 pi epsilon naught P cos of theta. For axial point, cos of theta value is 1. So P multiplied by 1 upon R square. So P multiplied by 1 means it will be written as a P. And then you will get this potential along the axis. And the second special condition is, if your point P will be lying on the equatorial line. So equatorial line means the line which is passing through the center of dipole and perpendicular to the axis. So theta value is 90. If theta is 90, so I will say cos of theta, which is equal to cos of 90, will be written as a 0. And therefore electric potential along the equator due to dipole will be reduces to 0. Why? Because cos theta is 0. So here I can put cos theta is 0. 0 multiplied by P is 0. So your electric potential along the equatorial line will be become as a 0. So these are the two special cases for your electric potential along the dipole. Now we are going to consider the next point, that is, if I am going to consider electric potential due to multiple charges. So due to multiple charges means what? Here your point P will be surrounded by number of charges. So let's consider here is your Q point, and this Q point will be surrounded by number of charges as a Q1, Q2, Q3 up till Qn. While this Q1 charge will be at a distance of R1, Q2 charge will be at a distance of R2, Q3 charge will be at a distance of R3, and Qn charge will be at a distance of Rn. So what will be the net potential at point P due to this multiple charges? For that, we can consider the basic equation. Your electric potential due to point charge can be written as 1 upon 4 pi epsilon naught Q by R. Now here first charge I can consider Q1. Its distance is R1. So corresponding potential I can call it as a V1. So potential V1 will become 1 upon 4 pi epsilon naught Q1 upon R1. Similarly, electric potential V2 due to second charge Q2 at a distance of R2 can be written as 1 upon 4 pi epsilon naught Q2 upon R2. Similarly, I can write for V3. V3 means electric potential due to Q3 charge at point O at a distance of R3 is 1 upon 4 pi epsilon naught Q3 upon R3. And similarly for N charges, Qn charge, which will be at a distance of Rn. So Vn can be written as 1 upon 4 pi epsilon naught Qn upon Rn. And now From that, I can find out the net potential. So already we are knowing that electric potential is a scalar quantity. So as it is a scalar quantity, so its net potential V can be written as V1 plus V2 up till Vn. In that, 1 upon 4 pi epsilon naught is a common quantity. So as it is a common quantity, I can write down 1 upon 4 pi epsilon naught is a common quantity. Inside the bracket, I can write down Q1 upon R1 plus Q2 upon R2 plus Q3 upon R3 up till Qn upon Rn. So this is your electric potential due to multiple charges. Same equation I can write down in generalized form, and I will write down electric potential due to multiple charges can be written as 1 upon 4 pi epsilon naught summation of Qi upon Ri, where R will stands for 1 to n. And if charge distribution is continuous, then this summation will be replaced by integration. So this is about your electric potential due to multiple charges. Thank you.